looks like we're here. Yeah, hi everyone. As always, my name is Zach. I'm just trying to make sure we are online correct. Cool, it seems like we're online correctly. Yeah, first of all, good news. I got a working Tiny Clunks. The other one that I got before wasn't working, so I got a replacement one and it's working. So we're gonna explore that at some point soon. That would be nice. Yeah, so what are we gonna do today? First of all, let's do introductions. So hi, my name is Zach and I'm an open source software developer, and I'm spending December trying to get very familiar with Verilog and digital design, and I'm trying to get this intuitive, so I'm trying to do a lot of daily posts or daily studies where I make sure I use whatever other people do advent of code, and I'm going to be doing advent of somehow learning FPGA. Previously on the past stream before this one, we'd worked on what was this? We'd worked on micropipelines by Ivan Sutherland, and we were trying to build a seemingly sender-receiver application that we didn't get quite completed on. I think there was an issue with some ping-ponging of signal between both of them. This is somehow a deeper issue that we need to kind of find out. So I need to like go through more Verilog before I go back there, and we can see what happens there. And pipelines are not easy, so there's never an issue with that. So this is the paper that we were looking at the other time. Or rather, let me not do that. This is a paper that we were looking at, asynchronous design using micropipelines. And what we really wanted to implement was one of this transactions described here. So I'll just zoom in a bit so that they're quite obvious. What I wanted to implement was this transaction observed here. However, it didn't exactly work out the way I wanted it to work out. So we'll get back to that at some point after reviewing more Verilog and reviewing more digital design and kind of getting more comfortable with stuff. So we're still on week 3 of a hands-on FPGA, and I'm gonna do this, I think, until I finish all the weeks, not just until we finish hands-on FPGA. I mean, not until advent of code, and I'm gonna do it until I finish all the weeks. So one of the suggested advanced challenges was to analyze some Verilog code we found in the 8-bit workshop. This is, if you know my channel and if you watched this before, this is kind of our favorite thing to do. We like looking at code, we like learning it, we like just kind of reviewing stuff that exists and learning from there. So I thought, what better way other than to just since I couldn't write Verilog today, since I'm kind of discovering where to go, why don't we just take some time and discover what some Verilog and go through it. So when I got here on 8-bit workshop, so it says 8-bit workshop there. When I got here, you can choose a few things. You can choose a clock divider, which I think it's pretty, we've done this before, we've done this in a few versions. And you can also choose a binary counter, which we've done before. As you can see here, this is the way the counter works, and then there's a display there. So I chose the next best thing, which is a video sync generator. I think this is a VGA sync generator for like RGB signals or something of the sort. Yeah, you know. So an easy thing to do would just to be like go through this, try and break it down, and try and see if we can kind of understand what's going on and discover what's going on, and then this would be a really, I think this would be a really good way of learning stuff. So it's not very long. It's something like 70 lines of Verilog. We can kind of discover it. Maybe, no, I don't have that much time today. It would have been a really good thing to try and write a test bench for this. But let's not focus on so much on writing today, but rather like reading and kind of discovering what the stuff is. I want to open the quick reference, and then we can go on, and I'm going to zoom in here quite a bit so that it's visible, and we can go from there. So what we want to do is discover what this module is doing and how it's doing it, so that we ensure that we basically, you know, find out something that we didn't write ourselves and see what we can do with it. As a reminder, let me just do my Discord update. Yo, wow, I'm so careless, yeah? Oh yeah, sure. How do I do this? Yeah, I can use OBS and I can turn off my screen capture, and then I can go here and I can choose Discord here, and I can move Discord to the other side. And then from here I can go back and sort of like start my screen capture again. And then I'm gonna go to Discord and I'm gonna tell the group that I'm online. This is online now. Okay, cool. So perfect. So let's actually do some stuff. So what we can see here is a video syncs generator to drive a simulated CRT, an RGB CRT, and then it adds a 3-bit or more RGB output to the top level. So this is just basically, you could probably connect this to you could write this Verilog and put it on a little FPGA, and you could connect the output wires to some CRT, and it would just generate some colors. You know, you would see colors that were coming from the hardware that you wrote. So we want to see what this does and try and understand it. So it starts out as a module with called HSync generator. It takes in a clock signal. It takes in a reset signal, it takes in a horizontal sync signal, and it takes in a V sync signal and a display on and a H position and a V position. So if you remember, when we looked at MIPI, FPGA graphics, let me do FPGA graphics. I just need an image that shows how these things work. FPGA graphics, and so we can see what those little symbols mean, and then in good time also. So yeah, so let's open this picture. So basically this is how the drawing on the screen happens, you know. And so if we follow these, so there's a clock and there's a reset. Those are normal ones, we don't really care about them. HSync and VSync happens to be that HSync tells us every time, HSync basically blips every time we get a complete line. So in this image, whenever this pixel reader or pixel writer goes, because there's CRT raster, okay, cool. So basically whenever this pixel reader or writer gets to the end here, and it wants to go to the next line, we get a H-sync blip or a horizontal sync blip. And then whenever it gets here at the bottom of this, we get a V-sync blip. So we know when we've finished the line, and we know when we've finished the frame. Basically, that's the names of those signals. So basically here, H-sync tells us whenever we've done a line, and V-sync tells us whenever we've finished a frame. And so it goes across all the way to the bottom, and that's a frame. And the moment it finishes a row, that is a line, that is a horizontal thing. And then we have an output which is display on. Okay, cool. This is just an output. And then we have an output which is register, which is a 9-bit register. And then we also have a H position 9-bit register, and then we also have a 9-bit V position register. Cool. So we have some outputs, we have some inputs, and it's quite interesting in that you can see this inputs and outputs are labeled after the module generation is done, module declaration is done. Usually the way I've done this before is I would label them in here, whether they were inputs or outputs. And also during some sort of studying this weekend, I sort of discovered that you can have an in-out, which is an input-output or something, sort of port. And ports are quite interesting. They get quite more interesting in the future. So, declarations for TV simulator sync parameters, horizontal constant. I want to know what parameter is. I want to know what parameter is. Parameter. What is parameter? Parameter value assignment. Parameter value assignment. What is a parameter? It's just a value overriding parameters. Let's go Verilog parameter. I haven't used Verilog parameters before, so I want to know what they are. Verilog parameters. Parameters are Verilog constructs that allow a module to be reused with different specification. For example, a 4-bit adder can be parameterized to accept a value for the number of bits, and a new parameter and new parameter values can be passed in during the module instantiation. So an n-bit adder can become a 4-bit, 8-bit, or 6. Okay. So there really are parameters. So you could make an adder. You could make an adder like the ones we've made before. We made RTL adder. So this adder that we've made before, we could parameterize it. We could parameterize it so that it ends up not being 8-bit or whatever. So you could use this as parameters, and whenever they're passed in, the adder could assume whatever. It could be a 16-bit or 32-bit or something. Okay, cool. So it's just this is something that can be used to change them. They're like arguments to a function that are passed in during a function call. Parameters are basically constants, and hence it's illegal to modify their value at runtime. It is illegal to redeclare a name that is already used by a net variable or another parameter. There are 3 major types of parameters: module, and specified. Types of parameters. There are 3 major types of parameters: module and specifier, and both accepts a range specification, but they are normally made as wide as the value to be stored requires them to be, and hence a range specification is not necessary. Okay, cool. So this is something we can pass into the module that determines, so let's say we had like a 16 by 16 FPGA, I mean a 16 by 16 CRT, then we could set the H display to 16 and V display to 16, or you see, so here the display width is 256 by 2 and the vertical height is 240. So these could be set. You could declare this in such a way that the module gets them, and they could be set from outside if they were passable into the module. As you can see here, parameter bus width and all of those, input add write data, but so wire. But I don't see, so FIFO, okay, design code goes here. So what can I change here? What can I change here? And then how do I, so when I'm test bench, oh, so whenever I'm, so this is, you see this bus width here is 32 and data width is 64. Whenever I'm instantiating the module from somewhere else, I can just instantiate it with a different bus width and data width. So it's actually quite important. So whenever you can design some sort of bus module, or some sort of like FIFO module, or some sort of like all of these modules, or RAM module that you just don't know how it's going to get used in the end. Whenever you make these modules and you don't know how they're going to be used in the end and how big they're going to, so you make an IP of some sort, a RAM IP, or say a SRAM IP of some sort, and because you don't know what size someone is, how much silicon someone is going to dedicate to the thing that you make, you make the parameters overridable. That way you can make a RAM module that could be 64 KB, 120 KB, all the way to like 512 KB, whatever power to that you want to, and so on and so forth. I see. So you could make the design and not you don't have to define the size of the design. But here in this context, they're not being overridable, or they're not being declared as being able to be overridden. Okay, so declarations for TV simulator sync parameters, horizontal constant. We have a display width, which is 256. We have a back porch. Now we go back here. Back porch is the period before the first pixel on the row becomes valid, basically. You see, there's a padding here. There's a few padding, so when CRTs were actually moving, electron beams, then this was the time it would take for the CRT to move from here to the next line, from here. So in here, you see this time, this dotted time, this was where this was the back porch. But now that we do stuff that has basically addresses, basically pointers, and this doesn't take time at all, this space can be, it has been maintained. It still exists. So this space ends up being used for things like audio synchronization, or if you want to do things like stagger images, stagger frames, so that you can patch a lot of frames. You want to make a 360 image, or like an augmented reality image that is all the way around. You can basically set, or you make a panorama of an image. You can give everything a different back porch and a front porch, so that it so that they line up properly. They line up in a way that you can use 5 pictures, you can use 5 cameras and take 1 picture at a time, but then you could enable them to end up becoming one big panorama of some sort if you want. Cool. So the horizontal porch, the front porch, and the back porch is the back porch is the time before the valid pixel, and the front porch is the time after the padding, after so it's kind of half. The half here that is coming this way is the back porch, and then the half here that is getting here, a half of this dotted line is the back porch, and a half of this dotted line is the front porch. So cool. So that is what is declared there. So there's a front porch and there's a back porch, and then there's a horizontal sync width. Do I remember what the sync width is? Sync width. I think the sync width is, yeah, this. What is the sync width for? I think it's also, it's just place Control F sync. Horizontal sync on a new frame, sync width. So I don't remember, but I know it's the padding after, and the vertical has a front porch and a sync width after a sync width after the vertical of the front porch itself. Okay, cool. So this is what happens after the horizontal front porch, and the same we have on the vertical line. We have a 240 height, and a top border that is 5, and a bottom that is 14. These are paddings, and then we have a sync width at 3. And this back and front could be also this V back and V front. It still works. It's the same thing. Okay, so derived constants. H sync start. So display plus H front. Tell me, why is that the start? Ooh, I know. Remember this thing. Remember the thing about binary counters. If you get to the end, and you add 1, you roll over. So basically this is just H front, because this is the end, and then you add front, the 7, so this becomes the padding. This parameter here, remember the rolling over concept? This parameter here describes this little pixel over here, basically this one over here, or rather the ones on this line, because you do all of this, you do all of it, and then you add that, and you just basically count all of that, and then you add this, which is basically count to the end, roll over, get here. That's basically what is happening there. And the H sync end is the H display plus H front, okay, plus H sync minus 1. Horizontal sync. horizontal sync. Where's the horizontal sync? Which is this? So H display plus H front plus this. So basically H sync end is there. So you want the signal, the sync signal, to stop there and for the thing to become real, because we're going to be using this sync signals at some point. We basically it's when you want to flip the sync signal. So now put it on and now put it off. It's basically, so when does the sync signal stop and start? That is, yeah, okay, I see now. So look. You see this horizontal sync? You do the width of the thing, and then you add the front punch, the horizontal sync starts here. So let's actually save image as downloads as display timings, and then here let's actually go to Excalibur. Does anyone have any questions so far? Let's remove that, and then let's actually let's see, can I go here? Can I just make this a little smaller, and then can I go into downloads, and then can I go display timings over here? Okay, cool, done. And then I want to make this a little bigger so that we can actually describe this stuff. So we want this horizontal sync is going to be some register or some wire. Let's look at the code. Horizontal sync. Yeah, you see here, H sync, V sync. There you go. It's a 1-bit register. And what we want to know is when shall we give us a pencil and give us a red, and when shall we set it to go up? Okay, and when shall we set it to go down? Okay, what is this period? You see, what is this period? And this period is the one that we're determining, because this is the active drawing area, so the width of it, and then the front porch. So if we calculate that this pixels from here all the way to here, it gives us that. It gives us this value. Okay, and then if we go from here all the way to here, it gives us this value, basically. So the width plus the horizontal syncs, horizontal front porch gives us the start of the horizontal sync, and the width plus the horizontal front porch plus the horizontal sync gives us the end point of the sync. So if we go somewhere here, we're going to see that this is a H. This tells us when to flip it up and when to flip it down. Okay, and then H max gives us the display plus the back plus the front plus the sync minus 1. Oh yeah, because it starts at 0. Okay, good. So this gives us this H max gives us the whole thing. This is H max. Sorry, I'm gonna close this. This is going to be H max of so this is going to be H max. See, this is max. This is max. And this is H S start, and then this one is going to be H S stop. Okay, so that one is a stop. This is the max. This is the max of the thing. And then if let's go look at the other thing. The max and the VSync start, the same thing, VSync end, the same thing, and VSync max, the same thing. So and then we have the same concepts applied this way. So this one, that was a little lazy. So there's this one, okay, you see there's this one, and then there's going to be another one here, okay, and then there's going to be this one that goes all the way, and that gives us the 3 lines there. But I think we went the first one was to here and the second one was to here, and you know, and oh sorry, there's this one that goes all the way here. There's that one. You see? So there's this one that starts here and goes all the way here, and there's at the same time there's this one that starts here and goes all the way here, and there's one that starts here, finishes here, and there's one that starts here and finishes up there. There should be one that finishes. Yeah, so this one should go probably all the way here, and then this one should go here. Okay, cool. So that gives us all of this parameters. So basically, we want to know when we want to know when we are here or here or here, and we want to also know when we are here, here or here or here. Another point of interest is also this one, okay, or here, okay. Okay, well, yeah, let's do that. Let's do that, and then this one out, and then pick up this one. Let's minus this one. Let's come on, Zach. Let's remove that one. Let's remove that one, and then this one we want to label it. Shit. Actually, so we want to know if we're here, and we want to know if so. And then these ones are the ones we want to remove. And then these ones we want to actually do them in red so that we show points of interest. So this is a point of interest, this is a point of interest, this is a point of interest. This is also a point of interest, and this is a point of interest. Okay, so yeah. So we have all those signals, and as we see, they're all defined all the way to here. We're already at halfway through the thing, and then we have a wire that is connected to Hmax, and the Hmax is Hpos equals to Hmax or reset. Okay, when Hpos is maximum, we want to reset it. Okay, and then when Vmax is maximum, we want to reset it. And the reset one, the reset line is an input, I think. There's an input one. Yeah. Okay, cool. So we know what happens all that time. So whenever if the reset is pulled low, then it's that. If it's pulled high, then it's okay. Then we know we're in reset, and we should do something. Cool. So let's keep going now. Now we get to the meat of this module. The meat of this module. So there's a horizontal position counter that tells us where we are on the row. Let's look at what it happens. So it starts on the positive edge of the clock. And what does this do? If it sets the H sync to be equal to in an unblocking way, it says the position is greater than or equal to H sync start and H pos is less than or okay. So this is set to that. We just set it to that. This is a true or false. This is okay. So remember this that we looked at here. We want to know when to start the sync or end the sync. We want to know when to start the sync or end the sync. So, and basically what we do here is we check, is the position greater than or equal to H sync start, and is the position less than or equal to H sync end. If it's greater than start and less than end being the everything, end being it's here, end being here, okay, end being there. If it's greater than start and less than end, if those two are true, then this is either gonna be true or false. What do we want it to be here? We want it to be, when will this restart? When will this return true? Whenever the position is greater than or equal to the start, We're looking at H sync start, not the horizontal start. Cool. So whenever the position is more than here or here, we want to set, yes, cool, that works, that actually. So this will return true if our H position is between here, and here, basically. I can also, let's use that and make a copy, and we want to go here. Let's paste a new one. Allow. So let's bring it. So that little parameter that we've seen, down that we're looking at, this little parameter here, hsync, is going to be true whenever we're greater than start and end of hsync. So this is going to be true through this area. Okay. So this. No, actually wrong. It's only going to be true in here. Hsync is only going to be true in here. Okay, cool. That's fine. So we only set it whenever we're not in there, it's off. So it's not syncing. Cool. Perfect. And then if H maxed, which means the position is at max, then we need to send H pose back to 0. If it's not at max, we need to say H pose is equals to H position plus 1. So basically, if the H position is here, we need to send it back to 0. If it's in here, if it's anywhere in here, if H position is here, we need to plus 1. So this is H. Okay, and then this is H. So it's set to 0. If it's here, it's set to 0. If it's somewhere in here, if it's set, if it's anywhere before this one, basically, if it's anywhere before this one, can we erase this? Can we erase this? Anyways, if it's anywhere between here, all the way between, let's draw. If it's anywhere in between all the way here to somewhere like here, we need to advance it. Basically, we need to advance it. If we're not advancing it, we're sending it to 0. So this thing will be going all the way from start to beginning, all the way from start to beginning, start to beginning, start to beginning, start to beginning. Okay, cool. So let's think about it. So this moves the line from the left to the right. And then let's look at the vertical position counter. So this is fine. So whenever this goes left to right, is fine. And then we look at the vertical position counter. VSync, the same thing. The VSync start or VSync end. So we're looking at this area. Let's use green. So we're looking at this area down here. This area down here. This is VSync. This is VSync. And then the next thing we're doing is if it is H maxed, if H maxed, which is the if the H position has gotten to the max, so it has gotten to the end of the line. What we do, if it does and V max, then we send V position to 0. Else we add V position by 1. Okay. So look at this. You're looking for this value. If H max is between, let's use a different one. So you're looking for this value in here till here. So if this is not, this is H max, no? So if it's H max, HM, and not VM, if it's that one, if it's those, then you can, it's V plus 1. Else, the other option is it's both this, it's H max and V max. I need to get a stylus and then I can always draw this. And then if it's V max, then we need to do V is equals 0. So basically, if it's gotten to the end of the line and it's gotten to here, we need to go back here. If it doesn't gotten to the end of the line, just go to, if it was somewhere here, you would go somewhere here. So you go Like this would correspond to wow, it's so hard to draw a straight line. This would correspond to somewhere here, and then you would just basically here. If it was here, you would want to go to here. Basically, that's what's happening. That's what's happening here. So we are walking the screen, and we're walking the screen just as we're walking the screen. We're walking the screen. We're walking the screen, and all this does right now is it doesn't send any sort of RGB. There is an RGB somewhere. I thought I saw a RGB. No, there's only a H position and a V position, and we don't use. Why the H sync and V sync signals to the top level? Add a 3-bit or more RGB output to the output. Add a 3-bit or more RGB output to the top level. Oh, so you want us to add some sort of output. So we go like output reg 2 O. So this is 3 and vpos. RGB, and then does not appear the so here we want to set this as the RGB. Why are the H sync and V sync levels to the top level outputs? Oh, does it want us to do that? So let's do wire H sync wire so what are we wiring? We're wiring H sync to pause. Wait. It wants us to do something here. So it wants us to wire the H sync and V sync to the top level outputs. So these outputs, and we want to set them to H sync or V sync. Well, it is wired. They are wired here. So I don't want to set them. What I want to do is this is going to 0. This is going +1. So what I want to do is something like RGB is equals we want to set this one to equals random. Well, we can do 3b okay, yeah, 3b 3b1. Let's set everything to 1 so that it actually drives. So, and then this is as it's driving. So every pixel we're setting it, every cycle we're setting it. So, and then what's happening here? What is happening here? So if we simulate this, what's happening? So RGB is always 1. But this is not always 1. Let's see. RGB 0, 3b0, 52. So why is this one not getting set, and why does it actually break when I do this? You see, when I do this, when I drive this, it breaks. That's fine. It's not driven. I understand. I can actually comment it out so that we see. No, in out. Okay. Yeah. Okay, so there's a problem. There's a problem. So we can't remove this. We can't remove this, and it wants to RGB. It wants to fail when we do that, and then if we go here and we say output reg, can we stop this? Can we stop this for a while? Output reg, and then we want to do 20 RGB. So what we want to do is RGB signal is not driven. When do we wanna we do wanna drive it whenever I wanna draw the pixel as I go this way. I don't care about drawing it when I'm going down. I wanna draw the pixel when I'm going across. So I wanna put a pixel, 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 put a pixel. And what I wanna do, what I would like to do, this is just fine right now. This is just fine right now. I would like to do whenever this is, I'm in a valid pixel position. Valid pixel position. So if I could do RGB and I could set it to 3B 1 1 1 and that, but this is sort of like it breaks my simulation. It's 1 1 1 3 or 7. Can I do 7 like that? What's the problem? Why does that break my simulation? Why does that break my simulation? Because this is now clocked. This is now set. Do I want to do an RGB set? Okay, so here yeah, I could actually do that. Wire RGB. No, wire pixel maxed equals let's think about it. How do I set, why does everything always become like writing code? How do I set this RGB in a valid place? Oh, I think I know what I know how to do. I could just assign it somewhere, but how do I could actually calculate something. Let's do here. So yeah, assign RGB is equals we want to assign it to yeah, HPOS is less than HDisplay and VPOS is less than VDisplay. Yeah, I could use basically that. If I do that and I do that like that, what's wrong? I see now the error of my ways. Can I do this? Always drive RGB value. Let's say that always at pose edge clock. Okay, and then if h pose is less than h is great is h pose and v pose are these signals here. FPGA graphics. Moses is asking FPGA graphics. Moses is asking what are h pose and v pose. You see this dot, it is at a particular h pose, horizontal position and vertical position. Basically, whenever you're looking at a screen, it has a lot of pixels. It has something like 50 pixels by 500 pixels, something like that. So h pose is which pixel it is on the horizontal line, and v pose is which pixel position it is on the vertical line. Moses is asking, what does h pose and v pose mean? Cool. So I want to do, if h pose is less than h display, okay, check. If h pose is less than h display, and yes, it is x and y. It is x and y. And oh yeah, I think I need these ones in here. And h pose is greater than v sync end, h sync end, front and back, h front, h sync. Front and back, h max, yes, and greater than h max. But what is h display? Yeah, has to be greater. It has to be less than it has to be that, and then it has to be greater than h sync n, h max. H max is everything. That's the start. So basically it has to be greater than h sync end, which is the front and the sync. The front and the sync, isn't it? The front and the sync, but here, but the plus the back. So, and this is the max. This is the max. So if it's greater than the max, if it's less than the max, if it's greater than the max, no. I need to check when it's somewhere in here. So let's think about this. So it has to be sync start, that's no, sync end, that's no. H max is display plus that plus front plus sync minus 1. So that is that it has to be greater than the max. It has to be greater than the max and less than the sync start. Yeah. It has to be greater than the max and less than the sync start. H max and H pose less than H sync start. Yeah. And then I still want to come back here and add another one. Oh man, why is this, why does this do this? Why does this do it like this? I hate this editor. So, and we also want to do a begin. And then we want to say if, and then H pose is greater than greater than h max, and is h pose, oh come on, h pose is greater than h max, and h pose is less than h sync start. We want to choose where we so there, and then v pose and v pose greater than v max, and greater than v max, and here I didn't need this one, v max, and v pose is less than v sync start, and then we want to close this and this, and then do a begin, and then in here we want to do RGB is gonna be like equals to 3 B 1 1 1, and then that, and then else isn't it, else RGB is less than or equal to 3 3B 1 2 3, and that's it, and then this, and then we can go end, and then we can also go I think the always also needs an end. Yeah, the always also needs an end. And yeah, and then what is this? Okay, so if da 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 da, if da 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 da. Is there a begin here? So there is an end. Else. Actually, yeah, else. If else Verilog. If and else if and. Okay. Can I do a default? Excuse me. Else. If. Else. Please. Can I do a default? Excuse me. Yeah, if else if begin, yeah, I'll just do a begin and an end. We can also just remove that. I see. So they actually didn't end up using here. We can just remove this begin, and then we can come back here, and then we can use an else here. Else RGB. We can set this to dark. 3B, 3B, 1, 2, 3. There you go. They stabilized. Haha. Oh wow, we did something. So what happens? I want to look at that. I want to look at RGB. I want to look at RGB, and I want to walk through it. When is RGB ever set? RGB should be set at some point. RGB is oh, is it? I'm seeing H maxes, but I'm never seeing RGB getting set. The last assignment else. What does FPS affect? FPS. Where do you see FPS? Oh yeah, there you go. It's set. It gets set. Yeah. RGB gets set. There you go. It's set. It's getting set as 3. 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 But I have a feeling until we find whenever H-sync is set, yeah, not H-sync. I wanna go when V-sync is being set. So what we want to do here is want to do else if HPOS is we want HPOS whenever it's more than max but less than sync start. Whenever it's in sync, HPOS is more than sync start or less than, else if HPOS is frames per second. That depends on how many times you draw the, that's just a timing constraint now. Moses is asking, does FPS affect? So it depends on how fast you want to do a frame basically. But because you're writing hardware and we can oftentimes do things in t equals 0, so we can do them immediately. It's FPS does not come into play. It usually comes into play when on the thing that comes after this thing, not on the hardware you put on this hardware, like the screen, not the driver of the screen. HPOS has to be over H sync start and HPOS should be less than H sync end, and then and VPOS should be, and VPOS should be greater than V sync start and VPOS is less than vsync end, and then that should give us this and else, and then in here we want to do it should go that way. RGB is less than or equal, well, this is an asynchronous set, 3B 1 2 3, that I think so. That should be it. what are you saying? There's an issue at. So this probably ends at the end. No. So H pose and that one and that one, and then this one. Oh yeah. So this can be removed. Yeah. That should be okay. Yeah. And then what is the issue here? Can't they find vsync start? Vsync start. Vsync start. Vsync start. VCSY and K. Start. Yeah, so here it is. It kind of works. Let's go through. At some point it should be okay. Well, it never gets set. Okay, so it never gets set. There's something we're doing wrong. There's a way we're setting this that is actually wrong. The way we're doing this, this condition is always winning instead of that. So we need to check that out. Anyways, it's 5:30. I have to run to a meeting at work. Thank you all so much. We've looked at how a CRT driver would be done in hardware using Verilog. So this is there's something here that is quite difficult for me, which is setting these values. They always end up tripping me up. So I'm gonna actually come back and look at them. So is it Vmax? More than Vmax, top bottom vsync -1. But less than vsync start. Vsync start, it's there. V display top bottom. Yeah. Well, anyways, thank you so much. That's been awesome. That has been reviewing the CRT video sync generator. Thank you. This actually is quite cool because we're just generating the timings for the video sync. It's not really that we're trying to draw, but it does say here add a 3-bit or more RGB output to the output level. But we'll come back to this later. We'll try and understand it. Thank you so much for joining my stream today. That is video sync generators in Verilog. Digital logic coming along. I still can't find a way of like balancing my sequential and asynchronous things. Thank you so much. My name is Zach. Remember to be daring. See you all tomorrow when we do something else. Cheers.